Good morning. I'll tell you in this short demo what I have done so far on my gender detection task. I'm using MATLAB 7.12 version for this task, and the database that I'm using is the Ferret Color database. Well, as regarding the images, I'm using only the frontal images that are FA and FB for both for training and testing. For female, I have selected for testing, I have selected 103 images, and for training, I have selected 150 images. All of these images are manually cropped to the size 32 cross 32. These are the female testing images, and these are the training images. They don't consist of any duplicate images, so only for a single person. uh, I haven't used duplicate value in training and testing. A single subject appears either in training or in testing, so they doesn't consist of any duplicate values. And this is the male database. For testing, it consists of 143 subjects. These are the 143 subjects. It consists of different cases like men with long hair, with mustache, beard, bald, with glasses, different kind of and different ages, and person with different ages are considered. For feature extraction, I have used the LBP operator. It's also implemented in MATLAB, and for every single person, 59 features are extracted. I can show you these over here. The female test set. As you can see over here, the data is in the correct format. For the SVM, it consists of the label, the index, and then the feature value. So for it have 103 images in the female, and it consists of 59 feature values, as you can see from here. These are the 59 values, and all of them appear in the proper format of the SVM. Similarly, I have used such format for training and for testing. And the file, this is the gender complete file consisting of the training and the testing data. I can make it larger so that you can see it here. For the male, I have used +1 label, and for the female, I have used -1, and for every single image, 59 features. So that's all with the feature extraction. Now for classification, I have used a library SVM 3.11 with MATLAB interface. So this is the MATLAB interface that I'm using. In the library SVM, we have in MATLAB we have one method to use the training, and other we have used to predict the accuracy. So first of all, I have used some methods to normalize my data and to perform scaling, so that the value just lies exactly between the -1 and the +1. So for first, I have to perform the pre-processing of the training. Here it just read the training set, remove duplicate value, and here I'm using the scaling so that it can properly, and to find out the best C, best G value, and to give a plot. So I'll just run it and we can see it from here. It's performing the optimization to find out the best C and the best G values on the whole training set, which consists of both male and female images. So here we go. This is the plot that shows us the best value that it has find out. For C it's 4 and for gamma it's 0.25, and the accuracy that it's showing is 71.7687, and for C it's using the log 2 C, and for gamma it's using the log 2 gamma. From here we can see the cross-validation accuracy as 66.667, and for C it had found out that we can use 4. For C we can use the value 4, and for G we can use the value 0.25. Now we will do the training of the SVM with these values, and we can easily check the results. So for that we have the formula. We have to supply these labels and the matrix, and these are the different parameters that we can vary. So first of all we will use the kernel that we are using, RBF, C equal to 4 and G equal to 0.25. Okay, so that's the number of subject it identifies is the 271. If we want to make a plot, we can use it's for the training. We can easily, oops, let me just, because I guess I didn't use. Okay, so that's the accuracy, 78.23%. 230 subjects over 294 is the classification accuracy. This is the ROC curve for the training. Now we can use the prediction to find out the prediction accuracy. First we have to pre-process the testing data, same as we did for the training dataset. We will run it. It will find out the whole labels that are used. Now we can easily predict the accuracy from here. Okay, it will find out the predict label, accuracy, decision value, and here we are using the labels and the feature value and supplying the model that is generated by the SVM. So we get an accuracy of 78.2313%. Now if we want to plot a curve, we can easily do it and just change it, level test 2 and instance test 2. That's all. Okay, so this is the ROC curve we can see from here, an AUC of 0.84 as the accuracy is 78%. AUC is the 0.84%. Now if we want to change the parameters in SVM, we can easily change the training parameters here. If we want to use And also if we want to do cross validation, we can easily supply the folds that we want to do, either 10, 5. So that's, and if we want to see a plot for it, I guess the same accuracy. Now again, prediction, same accuracy. I'm using here minus S0. It's a CVC, classification SVM. Now if we change the this SVM to NU SVC, we can easily see the changes. Okay, so the number of biased subjects is 94. Now if we want to do a plot, we can easily. As you can see, the curve is improved and the value is now 0.966. If we use SVM predict, okay, now the accuracy is improved. We get 91.4966 accuracy. 269 subjects over 294. That's a classification. And if we want to try some other kernel like linear kernel, we can easily do it from here by changing the kernel parameter. One is the polynomial kernel. Now the number of bias subject is decreased. It's now 72. If we want to do a plot for it, we can easily do it from over here. As you can see, now the AUC value is 1. And if we want to do prediction, we can easily do it by supplying that model that is generated by it, simply pressing enter. So you can see now we get accuracy of 99.3197%. So the accuracy is improved. And if we want to do a plot for it, we can easily do it from over here. So I guess that's what I've done so far. I also tried to do classification of a single subject, a single image, supplying it to the SVM, but its accuracy is not just improved. I'm still working on it, and I'm also trying to implement it in real-time system. I have find out some codes, and I'm working on some codes to use the webcam or some other camera that we can connect to USB, but it's in progress. I'll show you when it's complete. So that's all.